We were the first and only U.S. team to qualify for RoboCup in the humanoid division. So we successfully managed to make a robot that's autonomously plays soccer. We learned a whole lot from competing last year, and we think we're really going to be ready this time to compete and even win. So we're really excited about this upcoming year and our upcoming design. One thing that we didn't have design our robots initially was protection. We came to the RoboCup and we didn't have anything protecting our robot when we fell, so we just put 2 giant screws coming out his chest. We realized that wasn't the best way to do it. In fact, his head snapped off. He was running around headless for a while. But DARwIN is always evolving. The newest evolution is going from not only having a really intelligent platform with lots of sensors and very sophisticated platform, but moving it to a point where now other people can make the same thing for relatively low cost. So we're changing the way we're making the robot. We're making it out of materials and using methods that anyone could use relatively cheaply. And we're going to publish all of our plans online so that other robotic researchers can use their own code and their own programming and put it on the robot to test out their ideas. So we've done all mechanical design work and allowed others to test out their algorithms and code. We don't have buttons on our robot yet, and sometimes you don't have a wireless connection. So we actually taught the robot to read signs. So I have a sign here that says handshake. So I show the robot the sign handshake, and it actually reads the words on it and sticks out his hand, so I can grab his hand, and it senses the force on the end of his hand and actually shake my hand. Additionally, we have taught it to play a game. We have a dice game that we play. So I show him the sign that says dice. So show him the sign that says dice, so he's ready to play dice. So I'm going to take the orange dice, and I'm going to give him the maroon dice. So he goes ahead and throws it. And so he got a 4, and he's telling me, oh, it's my turn. So I got to roll my dice, and so I roll mine. I got a 6. So now the DARwIN looks at the 2 dice and using a LabVIEW vision control and identifies which dice is his, and then counts the dots on the dice to see if he does it successfully. So he lost, so he's sad, and that's just sort of crying and wallowing in his own misery. The thing is, we program on a PC-104 board, which is just a generic computer. We happen to be using LabVIEW Real Time just because we've been using it. We feel like it's one of the easier platforms to use, especially in academics. It has a very easy learning curve. But if you prefer to program in C or Microsoft Robotics Studio, that's still, you can do it. It's a generic computer, so you can program it in whatever language you want to. But we happen to use LabVIEW because we believe in it. Especially in the academic realm, we're always bringing in new undergraduate students and new researchers. And as mechanical engineers, we don't have time to learn C++ or programming. And LabVIEW allows us to do that, really get people learning how to program this stuff really, really quickly. I would personally like to stay in research and development and robotics. I'm really interested in it. If not, robotics, sensor fusion, and sort of autonomous vehicles is what I'm really, really excited about. Thank you.